Welcome back. And today I will lecture about the triangle waveform oscillator. This lecture is the G30 program, international program in Nagoya Universities. Okay, and seventh one today. And what is a triangle waveform oscillator? This is including in the boost chopper. We have running in the sixth lecture is the DC-DC converters total systems lecture. And we have analyzed the power circuit and the gate drive circuit, and we have run in the transient phenomena because of the using in the drive circuit and triangle waveform oscillator. And including what in this total system of the boost chopper, what is a triangle waveform oscillator? That one is here. This is a triangle waveform oscillator. Comparison with the signal or the acceleration of the automotive speed detection or the speed. This means the really change to the voltage and voltage change, and this is the oscillator, that one. This circuit is that one. And comparison with each voltage waveform, the output of the comparator is like the pulse. So we call this one is the voltage pulse. And changing the voltage width, we can control the output voltage. And output voltage connect to the DC. In case of the DC motor, we can control the speed by the acceleration. So we call the changing the pulse width. We can obtain the output voltage, variable output voltage. So we call the PWM, pulse width modulation control. That is we have lecture in the lecture fourth one. We have discuss the detail. So please check the later. And today we will discuss the triangle waveform. This line, triangle waveforms, this line means this line. Okay? This line, this is the output power line. Power, not power. The oscillation voltage line. This is a V triangle waveform. We can obtain the terminal of the ground side and this output terminal. We can obtain the triangle waveform. How to generate the triangle waveform? We will analyze today. Okay? Okay, let's discuss this circuit.よっしゃ、やるか。This triangle waveform oscillator is roughly divided in the two circuits. Can you divide? One is this circuit. This circuit is one. Another one is this circuit. Can you understand? This one is a comparator. For example, the 何でしょうか L, L, M311. For example, this one is a comparator. So the out of the terminal's voltage is only 2 voltage. We have only the 2 voltage. One is the positive side of the input of the comparator, and another one is the 0 of the terminal of this LM311 terminal. And in this point, we can obtain that only 2 voltage, 15 or 0. Okay, and first of all, in the terminal, time is 0. What is the voltage waveform in this voltage? VCT. What is the VCT? In case of this time 0 and T, VCT, K. 5 volt, 10 volt, 15 volt. Please write, indicate, illustrate the waveform transient of the VCT. Okay? Micharata. First of all, in case of 0, the no charge in case of the CT, this capacitor. So first of all, and this switch turn on, this circuit first operation. We must check this voltage. What is this voltage? Voltage value. The condition is here. And this terminal is higher. First of all, in case of T equals 0, no charge, there is no charge. So the first VCT is 0. So first point is here. In case of this term, so this is no charge. So this terminal's voltage is 0. Okay? VCT positive terminal is 0. So the minus side is 0. And other side, this positive side of terminal, what is the positive side terminal? The equivalent circuit of this blue line circuit. This is 0. This value is the someone. So in this case, the output voltage is the positive side, right? Okay. As compared with here, this one is higher than the 0. So the positive side is increase as compared with the minus terminal. So the output voltage of this comparator is the 15 volt. Okay. So first of all, in case of the red line circuit, please write the equivalent circuit in case of the terminal 0. Red line circuit and blue line circuit. Okay. Okay. First of all, the 15 volt. ブルー書くな。ブルーこれで書いていいか。ポジティブプラス R1 This one, equivalent circuit. So, what is the voltage over here? The condition is here. Very easy. Volt. So the positive side terminals, this voltage is the constant voltage of the 10 volt. Okay. On the other hand, the red lines equivalent. What is the red line equivalent circuit? Please indicate the red line side. Red line one is the equivalent circuit positive 15 voltage, resistance RT, and capacitance CT. We have learned in the fifth 5番目だね fifth lecture. Please check the fifth lecture. Transient phenomenon, the same equivalent circuit of the fifth discussion. In this case, no charge. However, the equivalent circuit is occur. So the current flows through like this, and this VCT increase like a transient phenomenon. Their target is the 15 voltage because of this input voltage is the 15 voltage. So this VCT increase to the 15 voltage. In case of the increase in the transient phenomenon, the voltage curve is shaped like this one. Okay? Remember? Okay? However, in case of this term, this circuit is changed. Why changed? Because this comparator's input voltage is changed. This plus terminal voltage is the constant voltage of the 10 voltage. But in the minus terminal, increase. But however, in this term, The minus terminal is the lower voltage as compared with the plus positive terminal. So the output voltage is constant. However, increase the terminal, the higher voltage in case of the minus terminal because of the positive side over to the 10 voltage over the positive terminal here. So VCT is over as compared with the 10 voltage. The comparator is the output voltage is a change. Change to the another voltage. Change to the another voltage, of course. Zero voltage. This voltage. Okay? So in case of the これあれつけるわ TA in case of the T equal TA please write the equivalent circuit of the blue line circuit and red line circuit. Please indicate. 書きますね。T equal in case of T equal TA first is the blue line. Okay. どうなるかな Zero. This terminal is zero. So volt terminal R1 R2 the resistance R3, this terminal is in this term is 15 voltage. However, in this over this term change to the zero, so this terminal to the down to the zero. So this voltage. This point voltage. This point voltage means that this point voltage. This point voltage is 5 volt. This line is the 5 voltage. Okay? In case of the red lines, voltage is charged in the VCT. VCT is the first overall. In this TA times TA, the charge in the 10 volt, okay? 10 volt. However, the voltage source is removed to the zero. So equivalent circuit is here. こうなのね。So, and charged, discharged, this loop, discharged. Okay? So, not increase to the 15 voltage. Time TA, this voltage discharged to the zero. Okay? So, from the distance, VCT, voltage VCT is discharged to the zero. Okay? However, this terminal point point voltage is changed to the another voltage. What is the voltage? Because this terminal's voltage is the 5 voltage. What phenomenon is occur in this timing? Please consider this timing's operation for the triangle waveform oscillator TB. After the TB, this VCT is the lower. The value of the VCT is lower than the 5 voltage. Reference voltage is the 5 voltage. But change to this minus terminal. Minus terminal is the voltage lower over the TB, timing TB, lower in as compared with the positive terminal, lower case. This one is the positive case, lower than this terminal. Output voltage is changed to change your back to the 15 voltage. Okay. And back to another equivalent circuit in each red line circuit and blue line circuit. Okay. So this time change. Okay. To another circuit. So this one is the positive one and charged again. Okay, because of this power sources occur in this terminal because of the comparator's operation. Okay, so occur to the 15 voltage. This VCT is increased to the 15 voltage. 15 voltage. However, change to this terminal, this timing, over as compared with this 10 voltage. This terminal 10 voltage to the 5 voltage, change to okay. So this terminal change to 0, increase, discharge, increase, discharge, increase, discharge. Far from this whiteboard, we can look almost the triangle. Okay. This triangle waveform oscillator is using the transient phenomena. We have indicated in the fifth lecture. Using the activity to this triangle waveform, we can obtain the triangle waveform. Okay, that is the triangle waveform generation principle of using boost chopper circuit. We later we can design in case for example from the customer. Please operate in the boost chopper. In the boost choppers, the switching cycle, switching frequency order is in case, for example, the 10 kHz. how to design this triangle waveform. Of course, you can already analyze the transient phenomena. So you can design this switching frequency for the boost chopper circuit. Okay? And in the next lecture, I will explain how to design this 10 kilohertz. Of course, very easy for because of the transient phenomena. You can already analyze in the fifth lecture. So please use this knowledge. And that in case 10 kilohertz, please design, G30 student, please design the 10 kilohertz each value, okay? Okay, that's all of only the principle of the operation principle of the triangle oscillators. Later, I will how to design the triangle waveform oscillator. Okay, see you.